All right. Hello, everyone. My name is Dane Hobreck, and this is a new series that I'm making about building a computer in Minecraft. The way I'm doing this is I'm going to be playing this game called Turing Complete. It's founded on the idea that you can build a computer uh, with purely a logic gates, namely the NAND gate, sort of like the seedling to start it all. So I probably shouldn't show that solution, but unfortunately, I didn't stream this soon enough. I already completed all the basic logics, all the logic gates, which I'll show momentarily. But now I'm on to arithmetic, and hence the starting title of the stream. So here is my world. It looks, by my standards, horrific in terms of layout. I'm just sort of having fun creating different versions of all these logic gates. Here, all the logic gates are completed. So we're going to continue on to arithmetic here. So I'll demonstrate just the NAND gate, maybe the AND gate as well, and then I'll keep going. This is largely for personal archiving preferences, but maybe someone might find this useful or enjoyable on the way. So yeah, I'll just start with the AND gate. So assuming an input, so for considering electrical systems, I have on and off represented here in all their various forms. So a redstone torch that's on is true, 5 volts or high. So basically that just means, let's just call that yes, okay? Off would mean false, 0 volts or low. So the voltages are relevant specifically in electrical systems, where if you're supplying current with 5 volts through a semiconductor, that wire would be live or on. And if it's low or 0 volts, it would be off or false. So based on that logic, we can create gates, logic gates. So this is called the AND gate. So two inputs, provided two inputs. Both inputs in this gate have to be live in order for the output to be on. So obviously I'm kind of already inverting the signal here with the torches. Just for reference, down means on. It could be a little confusing based on American standard house light switches. So, but yeah, so down would mean on in this case. Obviously that would turn off the torch and yada, yada, yada. But yeah, so this is what I would think is a relatively compact form of an AND gate. And the gate of interest that can create computers basically is the NAND gate. I believe you can also do this with the, can't remember if it was the OR or the XOR, I can't remember. But yeah, the NAND gate is pretty popular. So the NAND gate is just the inverted AND gate. NAND meaning not AND. So if I were to have both of these live, it would be off instead, as in contrast to the AND gate. So yeah, so we're just going to continue on. I am currently on the level in Turing Complete called Double Trouble. I actually completed it, but I have yet to transpose it into Minecraft, so we're going to start from there. This was my first attempt, bit of a mess. I accidentally was using 8 AND gates because I didn't count correctly. So I'm starting fresh here. So, all right, let's get going. I'm going to take a few blocks here. So in this first version, I already recorded what needs to be on, or what inputs need to be linked with what outputs. I should explain this. This is double trouble is what I like to call an at least 2 gate. So I'm not even sure if that makes sense, but essentially, if at least 2 of the inputs are on, then the output should also be on. So that could be all 4 are on, or just these 2. So yeah, we're gonna keep going. So this first input needs to be connected to AND gates 1, 2, and 4, and I have an array here, like kind of a 2D array, but it's really just one. I have an array here for mapping it. So obviously you have 1, 2, 3, 4, 5, and 6, and then that's 1, 2, 3, 4, 5, and 6. It's pretty self-explanatory. So this first input needs to be connected to gates 1, 2, and 4 And that's based off of this design. As you can see, these are connected to 1, 2, and 4, the first inputs. Ands accept 2 inputs, so we're gonna build that accordingly. So yeah, let me think again. First input connected to gates 1, 2, and 4. So it's gonna be simple enough doing the first one, but it gets more complicated when you keep going because of wires and overlap. So I mean, I'm thinking that, wow, nice, it was golden. So I'm thinking we could just connect that pretty directly. So there we go. There's 1. Then we need 2 and 4. So we need to go down 1, which actually should be simple enough if we just, you know what, just do that. It's not bad, actually. So yeah, look at that. We'll see if that actually works out as we keep going. And then 4. So 1, 2, 3, 4. So we got to go lower for the second one here. This is where it gets tricky because there's a lot of overlap here. So I guess we could just do this the standard way. I see, I'm kind of restricting myself to these general dimensions. Obviously, I'm going 1 block below the restriction I've set vertically. I typically have been doing that. That's there's kind of just a mental box around this, if you can imagine that. So you might think, why isn't he going lower, higher, or more to the left or right? But that's because, I don't know, that's just how my thinking works. So I'm trying to be intentionally restrictive. So let's keep going. Connect to that one. We could just do something really funny and just, as such. I go 1 block below because if you have a lever and there's dust directly beneath the block that it's powering, it gets powered. So just for your edification, I guess. So I'm dipping 1 so it doesn't connect there. Yeah, let's try that. Right. So that works. It's ugly, but it works. So we're just gonna assume that's okay. Let's keep going. The next one is connected to 1, 3, and 5. I'll also cross demonstrate that in Turing Complete. So there it is. It's kind of hard to see, but 1, you can take my word for it. It's connected to gates 1, 3, and 5. Okay, back to business. 1, 3, and 5. So, I mean, this is pretty good because I can't imagine there's much overlap for these last 2 inputs over here. So that should actually be perfect. So 1 is officially complete. It might be nice to mark how it's complete. So let's just do I don't know, let's do a green. Let's do this weird terracotta block because I hate terracotta. It's actually not bad. Just to say, this one's done. It's been fully connected because there's only 2 inputs. So now we're going on to, 1, 3, 5. So it's connected to 1. Now we're going to go to 3. 1, 2, 3. So that's right there. That's actually pretty convenient. This design's already looking much better than this. Yeah, I'm just giving myself more room here. So there's 1. Forgive my memory this today. It's, for whatever reason, it's very off. So 1, 3, and 5. So we're connected to 1, 3, and then we want to get to 5. So 1, 2, 3, 4, 5. Okay, that's gonna be fun. I guess I mean, I really don't want to go this high